In previous videos we've looked at if we've got a function or y as a function of x and we want to find the stationary points for this, we need to solve for dy by dx is equal to 0. And if you haven't seen this video, you probably want to watch this before, because it explains what a stationary point is. Or you can watch many of the other videos on YouTube that cover this exact same topic. There's lots of good ones out there. Yeah, and on that note, thanks for the support recently. We've been gaining quite a few new subscribers, which is much appreciated. So I hope you're enjoying the content, and please feel free to comment below any videos you want to see. But now we're going to look at what other information we can get about these stationary points. So if we found a solution x1, and that's the coordinate of our stationary point, we might want to see if this is a max or a minimum, or there are a few other options, but today we're just going to look at maximums and minimums. So what we want to do is find the second derivative, which is d2y by dx squared, or say, and then we want to work this out and then substitute this x1 value in, and we might have some other values that are also stationary points. And essentially, when this you know what, to show that we're substituting in points, we'll use a different notation. F double dash of x1 is less than 0. Well, this to change of the gradient. So if this is less than 0, this means that the gradient is decreasing. Okay, the gradient is getting smaller, less than 0, right? So the rate of change is less than 0, so the gradient is getting smaller. But we know at this stationary point the gradient is equal to 0. Okay, because that's the definition of the stationary point. So if it's decreasing at this point and it's currently 0, then the only way for it to go is down, right? Which means that we must have a maximum point. So hopefully that makes sense. And similarly, maybe we'll use x2 this time. We'll say second derivative x2, evaluated at x2, is greater than 0. Well, by similar logic but opposite, this gradient is increasing, and again at x2 the gradient is equal to 0. So the gradient is equal to 0 here, right? It's a flat line at this point, x2. So the gradient can only increase, okay? So that has to be a minimum point. Now what we'll do is we'll pick a particular function, find its stationary point, and then classify each stationary point. So we've got y equal to x squared plus 2x minus 3. So quickly we're going to find the first derivative. That's equal to 2x plus 2. I want to set that equal to 0. Since 2 is not equal to 0, we can just divide by 2. This leads to x equals minus 1 as our x coordinate for the stationary point. We will substitute this in to y just so we can find 4 coordinates. This is not necessary to classify the stationary point. Minus 1 minus 3. That's equal to 1. Minus 2. Minus 3. Minus 4, I believe. But you can never trust your own arithmetic. Yeah, so the second derivative is, well, this just becomes 0 and this just becomes 2. So we can substitute in our x, there's nothing to substitute in x. 2 is greater than 0, right? And that means it's greater than 0 or minus 1 too, so we have a minimum at minus 1, minus 4. But why, what does this mean now that this is not dependent on x? Well, it essentially means that the gradient is changing at a constant rate throughout the whole curve. If you plot this as a quadratic, and we see where our turning point will be, about down here. So this gradient is constantly increasing. You see it starts at a steep negative slope. That slope gets smaller and smaller negative, which is an increase, okay? Because it's coming from, say, minus 10 to minus 8, minus 6, right? It starts getting bigger and bigger and bigger, and then it starts to get steeper in the positive direction. And here's our minimum point here. So you can see how finding the second derivative can give us lots of information about the curve and about classifying minimum points. In the next video we'll possibly look at what happens when this is equal to 0. Sorry, that's just an arrow, but anyway, because that's just slightly more confusing, but not too bad. But for now, that's it for this video. If you did enjoy, please like and subscribe, and as I said earlier, thank you for your support, and I'll see you in the next one.